A printed circuit board contains a collection of connections, which enable electronic components to communicate with one another. The printed circuit board design depends on the application it is intended for. The most efficient way of working is first to determine whether the design meets the set requirements. This is done by computer simulation. If the design simulation fulfills the requirements, the first prototype printed circuit board is made. Until now, two basic techniques have been used to make circuit boards: hand wiring and etching. With hand wiring, the components are manually connected to one another with insulated copper wires. In the case of etching, the connections between the holes are made by etched copper tracks. However, these copper tracks cannot cross. For that reason, the so-called wire has to be used. This is a plated through hole to another layer. If there are two layers, the board is said to be double-sided. If there are more than two layers, it is a multi-layer board. There is now a completely new method for making printed circuit boards which combines the advantages of both hand wiring and etching: the multi-wire technique. The multi-wire technique uses thin insulated copper wires to connect up the components. The wires are 0.1 millimeter thick and are laid on the surface by machine. These wires can cross, which means that a high wire density is possible on the board. All connections can thus be made as short as possible. A multi-wire printed circuit board is manufactured in two phases: the layout design and the actual production of the board. The layout design for a multi-wire board is done on a CAD station, where a special multi-wire software package has been installed. The customer can supply the necessary design data for making the layout design in three ways. By supplying a circuit diagram, the data will then be entered manually by the printed circuit board designer. By supplying a diskette containing the data. By transferring the data online to the CAD station. The design data provides information about, for example, the dimensions of the board, the components, their dimensions and pinning, the position of the components on the board, the connections between the components, and any areas to be left free for experimentation. The computer uses this data to design the routing for the copper wires, using the shortest possible wire lengths. Together with the printed circuit board designer, the optimum component positions are determined. As well as determining the optimum routing, the CAD system also makes a number of production tools, such as masks, a drilling tape, and of course, the control data for the multi-wire machine. When the layout is ready, production of the multi-wire board can begin. The basic part of a multi-wire board is a glass epoxy board. This board has a 70 micrometer thick copper layer on both sides. These layers are used for power supplies and earthing. These boards must now be prepared for wiring. First, a layer of photoresist is applied. The appropriate masks are put in place. The power supply pattern is imprinted on the board by exposure. After developing, the layers are etched. A thin glass epoxy layer is applied using a press. An adhesive layer is then laminated onto this, and it is in this layer that the wires will soon be laid. The control data is entered into the multi-wire machine, and the boards which are to be wired are placed on the machine. Now the multi-wire machine can begin. The adhesive layer, which is still soft, is heated ultrasonically to enable the wire to be pressed into place. Once the wires have been laid, the adhesive layer is hardened by compression, and the wire positions are fixed permanently. In order to level off the upper surface, a glass epoxy layer is applied, which is called the pre-preg. This is then covered with a copper layer. These two layers are pressed onto the wired board under high pressure and at high temperature. The board is now drilled by a numerically controlled machine in accordance with the data on the drilling tape. The component holes must be drilled exactly through the wires. After drilling, the holes are cleaned. The insulation material is etched away slightly at the wire ends. This creates an optimum bonding surface for the plating through. By weighing, and if necessary, by optical inspection of a test strip, it can be determined whether the insulation material has been etched away deeply enough. The board is thoroughly cleaned again before plating through. Plating through takes place in two phases. First, in an electroless bath, the non-conductive areas are coated with a thin copper layer, which makes them conductive. This thin layer of copper is then thickened by electrolysis. Along the walls of the hole, on the ends of the wires, and on both sides of the board, a layer of copper, approximately 35 micrometers thick, has been deposited. After plating through, a check is made to ensure the copper has completely filled up the area around the wire ends. If the board passes the test, the outer layers must then be made, for pads and extra tracks, for example. Photoresist is applied again. Then the appropriate masks are positioned, after which the board is exposed, developed, and etched. If required by the customer, the copper layer on both surfaces can be used as an extra power supply or earth layer, as special tracks for larger currents, or for mounting surface-mounted devices. Finally, the board is milled to size. Now the prototype has to be tested to see whether it fulfills the technical specifications. All connections are tested to see if they are intact. Also tested whether there are any insulation problems between the wires or between the wires and the power supply layers, and whether the capacity of the signal paths in relation to the power supply layers is sufficient. Once the multi-wire board fulfills all the set requirements, the components can be positioned in the electronic workshop and soldered. The finished product is then given to the customer. The customer will now have to check whether his design works in practice. The choice between the multi-layer or multi-wire technique depends, amongst other factors, on the board requirements. The following are the most important criteria. Designing and, above all, routing a multi-wire board is relatively more easy than for a multi-layer board because the wires may cross. The design and redesign time for a multi-wire board is thus shorter than that for a multi-layer board. The copper wires on a multi-wire board may cross. This makes it possible to achieve a wiring density on a multi-wire board which is comparable to that of a 10 to 12 layer multi-layer board. The high wiring density on a multi-wire board does not necessarily mean that signals will affect each other more. The extent to which signals affect one another can be minimized by selecting optimum routing parameters. Of course, on both types of boards, it is possible to use analog and digital components. The application of large SMD components, for example, plastic leaded chip carriers, is more difficult in the case of multi-wire boards than in the case of multi-layer boards. This is because for each connection, a relatively large hole has to be drilled. This can lead to a shortage of space. The high-frequency behavior of a multi-wire board is at least as good as that of a multi-layer board. This is possible because of the short connections and because of the constant characteristic impedance. In fact, all signal paths are at the same distance from the earth or power supply layers. The manufacturing of multi-wire boards takes slightly longer than the manufacturing of multi-layer boards. For small series, the throughput time for multi-wire boards is generally shorter than for multi-layer boards in a normal working day. For large series, the throughput time for multi-wire boards is longer. With the new multi-wire technique as used at the Philips Research Laboratories, the printed circuit board design group is trying to fulfill the higher requirements which current technology and designers are setting for the quality of printed circuit boards. Multi-wire, the alternative way.